Okay, so now the last test that we're going to do, last thing that we're going to do, we're assuming to start with here, we've done all 9 tests. So here are our 9 tests. We have a chart that we're recording all of our data into. Okay, we got that data by going through our Q values and connecting our Q values. And realize, people, that's the beauty of this research. These 2 gentlemen, Mitchell and Stopp, who managed to get their PhD at the University of Michigan doing this whole program, this was the beauty of their research. They came up with numbers and they turned it into what's called a Q value. That's a grade. In science, that's really hard to do, and they did it. Okay, now you've already gone through these 9 tests. Here they are, and I'm just going to page through here and show you these 9 tests that we're doing. There they are. You guys got all your data. You took your data, and now you had to transfer that into a data sheet here, okay, that we have. All right, when you transfer this into your data sheet that you have, then what you're going to have to do is you're going to have to calculate what's called an overall water quality index. To do this, each time you did a test, you came up with a Q value. And so there'll be 9 of them that you record right down here. Here's your 9. Column A is the actual chemical numbers that you use. So for instance, in the case of dissolved oxygen, you calculated percent saturation. But that translated into a Q value. The Q value then is going to be multiplied by what's called a weighting factor. The purpose of a weighting factor is because not all tests are as important as others. I always told my students, if you could only perform 1 test here, I would do the oxygen test. As a matter of fact, when I teach river classes here at Riveredge Nature Center, I make sure that I have the students pick up rocks and look at the bottom of the rocks. If you see black on the bottom of the rocks, you got an oxygen problem. It's one of the simplest tests you can do. Well, we calculated that here, and its weight is 0.17. Go down to the total solids test and notice its weight is only 0.07. It's just not as important of a test. If you didn't have time to do all these tests, I would really try to do the first 2 because that's what's got the greatest weight. All right, that's the purpose of a weighting factor. You're weighting this. Now, you are then going to take column B, multiply it times column C, and you are getting a number here. Watch your significant figures, people. You can't just be giving us answers that's got 0.004 and things like that. You got to be accurate, okay, and watch your significant figures. So now you'll get a bunch of numbers that'll go down here. These numbers will be a little bit abstract because you've just multiplied that by what we call the weighting factor, but then the coup de grace, you total these 9 numbers and you will come up with a number that is not nonsensical. It makes a lot of sense, and you will get a number that is a grade for your river. When you get that number that is a grade for your river, so take a look at an example here. Here's some data that some people did. Some data. You can go further in your book. You'll find where there's some data that they put some fake stuff in, and you can see what they came up with. But you're going to get a number that's your overall water quality. Okay, if you go back early in the book here, there's actually a place on page 11 in this book where they give a grade. 90 to 100 is excellent. Let's call that an A. 70 to 90 is good. We'll call that a B. Whatever, okay? But what this allows us to do is it gives us a range for grade. That's no different than you sitting in your science class and your teacher hands you back a grade and gave you an 89 on a test, and you say, well, what is that for a letter grade? That's what we're doing here. We're turning this into a number, into a letter that you can then say, that tells me something about the river. So it gives us the overall water quality, which is awesome. But be careful about that, people. In any test, there are going to be things that are better or less than others. When I was in college many years ago, I took the ACT. I scored much better in math and science than I did in English. So something I always needed to work on in my life was my English. I needed to work on writing and things, skills like that. Same with a test like this. You may get a score in the B range, but you look at your fecal coliform test and you scored in the F range. Now you can focus on something that needs to be corrected. So never get, the overall number, that's nice. It tells you what, so you can compare rivers to rivers. But you always want to make sure that you're looking at the individual data, because it's that individual data tells you where there are problems. And no river is ever perfect. There's always going to be flaws in those. Now, I'm going to show you one last thing. If your teachers can't do all 9 tests, so I want you to go over to this board and we'll take a look here. If your teacher can't do all 9, so what if you don't do all of the tests? Here's what's going to happen. You're going to come up with a total score down here, but it's going to be missing a test or 2 or 3. And so this number is going to be lower than it really should be. And then when you go back to that page that I showed you before and you compare it here, your river's going to look bad. How can we normalize that? How can we make that something that makes some sense? Here's how you do it, guys. And it involves some simple math, some simple algebra, okay? I know you probably told you there'd be no math, but there is just a little bit of math here. So what you're going to do is you get this number here that's skewed low, and then what you do is go back to your book over here and total up all your weighting factors that you did do. It will not add up to 1. Had you done all 9 tests, these weighting factors would have added up to 1. This will be less than 1. This will be a number that's too low. We want to know what it would be, though, in comparison to 1. So you set up this simple ratio that I have written down here. Then, remember from your algebra days, cross, multiply, and solve for your total. And now you'll get a number that makes sense. Even though you admitted a test or 2 or 3, it will still give you a grade that you can then go over and compare to this over here, if that happens. Teachers, that's something that you can do. If I'm talking to seniors here, you're just sitting there going, that's silly, I get it. Freshmen, 8th graders, things like that, this might be a little more difficult for them to understand. So work through that, but that's how you finally get a grade and a rating on this. And then I also want to remind everybody then, once you get done with all this, we want to enter all this data, okay, up to Riveredge's website. I started doing this program at its inception in 1990. If you go onto the website, you can see my data from 1990 to 2013. That was the years I did it. And we have all our data for Grafton up there twice, 2 semesters always. We did it. We have our data up there, and it's very accurate, as do many schools in the Milwaukee area. You can go up there and get some pretty sweet data off there that you can compare to. And to me, that's the beauty of it. I just want to editorialize. In my career at Grafton High School, we steadily saw the river getting better and better and better and better. You always hear people criticize in environmental education that things just seem like they're getting worse. No, we saw our river steadily getting a little bit better each step of the way. That was a good thing, but we always had things we needed to work on. Okay? That's how you're going to perform this last function, and it finishes up your whole project that you're doing. Okay, good luck with it.